Okay, I wanted to do this problem because it's a sample problem involving one of the alternate functions. Here it involves secant. And I wanted to kind of go through my process for thinking about this. So first thing we're doing, I'm going to read the question. It's got a picture that accompanies it, which is nice. Standing on a shore of a lake, fisherman sights a boat far in the distance to his left. Let X, measured in radians, be the angle formed by the line of sight to the ship and a line due north from his position. Let X, measured in radians, right? So this is his due north line, and then X is the angle of his line of sight. Okay, right. So this angle X is measuring in radians, the angle between due north and a line of sight. So as the boat goes across, right, this is going to change. He sees the boat here, then he's got a new angle here, right? Okay. Assume due north is 0 and measure left, negative to the left, positive to the right. Boat travels from due west to due east. And the distance from the fisherman to the boat is given by the function d of x equals 1.5 secant x. Okay. What is a reasonable domain for d of x? So let's start with a little bit of domain talk here. And I'm going to go ahead and do a new share of a whiteboard. So we've got d of x equals 1.5x, sorry, 1.5 secant x. Oh, to go back to the days when it was just 1.5x. Life was good. Okay, let's remind ourselves about secant. So secant is 1 over cosine, right? Everybody gets a co. So if we're thinking about the cosine, then cosine looks like this. Whenever we hit 0, we're going to have a problem because 1 over cosine then would blow up. Also, this point here will be touching. So we're going to have these kind of matching parts. Let me use a different color for secant. So every time I have a 0, I'm going to get an asymptote, 0, 0. And then I'm going to have these little U shapes coming down here. Okay, so I basically got this situation. We know that 0 should be part of the domain because that's the point where he's looking due north and there's no angle. Then there's a little bit to the right and there's a little bit to the left. And basically, because the boat can't, the angle that he's looking can't go past this is kind of the limit there, then that makes pi halves from a positive side be the limit that we can go to. And on the other side, it would be minus pi halves, right? Because we can go this way, this way, this way. But as the boat goes up the shore, yeah. So the domain of this function has to be from negative pi halves to pi halves. And in fact, it should not be inclusive. I need to change these signs because I can't plug in the value of minus pi halves and pi halves into secant. Because when I put in pi halves to cosine, I get 0. And so secant would be 1 over 0, which is undefined, doesn't make sense. So this is my domain. This is the answer to the first question. All right, let's take a look at the next part. So then it says, graph D on this domain, which we kind of already started. In fact, we started with the graph and we kind of worked back to the domain from there. Discuss the meaning of any vertical asymptotes. Okay, so let's do that next part together. And again, we've kind of already hit all 3 of these first questions. So let's go back to my whiteboard here. I'm going to go ahead and redraw this focused from negative pi halves to pi halves. Here's my x-axis, here's my y-axis. Here is cosine. Oh no, I need that. I need a free form. Okay, so here's cosine and secant. Then let me draw my asymptotes as black lines. That one needs to be moved over a little bit. Okay. And so my secant graph is going like this. Coming up. Going up here. Okay. So as we approach pi halves, which means as the person turns closer and closer to looking straight down the shore, this distance gets farther and farther away, right? So as the boat goes farther and farther down and gets away from him, this angle goes more and more towards pi halves. We, in the kind of another nice way to say that is that, you know, the further away that they get, the less progress we make getting to pi halves, because there's very small changes in that angle as this boat gets further and further away. And it never can get to pi halves because that would be looking straight down the shore and the boat is not going to be on the shore. Same thing on the other side. Now I put this here because of the value of the value at d of 0, 1.5 secant of 0. Well, secant 0 equals 1 over cosine 0, and cosine 0 is 1. So that's equal to 1, so it's 1.5. So this should be 0, comma 1.5. Okay. Let's see what else is there. Find and discuss the meaning of vertical asymptotes, calculate d minus pi thirds, calculate interpret d pi sixths, and the minimum distance. Right. Okay. So let's go ahead and do whiteboard. So it asks us for a couple of particular inputs. D of minus pi thirds, I think was one of them. Yep, round to the second decimal place. Okay, so from a standpoint of calculating this, most calculators tend not to have secant, so we need to write this as 1.5 times 1 over cosine minus pi thirds. So in other words, 1.5 divided by cosine of negative pi thirds. I need to make sure my calculator's in radian mode. 1.5 divided by cosine negative divided by 3. Close the parentheses, check the mode. Yep, good. Okay, so I got 3 there, which makes sense because cosine of negative pi thirds is a half. So 1.5 divided by a half is 3. So that's this point over here. Negative pi thirds, comma 3. Then there was another one, which was d of pi 6. So we can go back through the same process. Secant pi 6, 1.5 divided by secant, divided by cosine pi 6. And cosine pi 6 . This time the value is not nice. Well, we can give it an exact value, but it's giving us rounded to 2 decimal places. I got 1.73. So that's going to be over here, pi 6, comma 1.73. So at an angle turning to the east, at an angle of pi 6, the boat is 1.73. What are the units on this thing? Kilometers away. Okay, we'll write that out in words. Let's clear some space for myself here. At a distance of rotation to the east, the boat is 1.73 kilometers away. Right, and the question about where is it closest, we've already answered. That's the one at the bottom of the U, which we get by plugging in 0. So for secant, the closest we get here, the smallest distance away, this value is 1.5 kilometers, and it happens when the boat is passing straight over the top of it. So it's due north of him. Okay. So it's interesting, you know, that these values kind of show up in these trig functions show up in interesting ways. But just wanted to do a sample problem for you, kind of see what that looks like, how the analysis looks like.